Hi, good morning or good afternoon, depending on where you're sitting today. I'd like to welcome everyone to another rail webinar. This is the second in the series of webinars designed for railroads and those who work with and support railroads. I hope that you enjoyed the last webinar, which was on mobility. I'm Mark Pesvic. I'm the Senior Account Executive for Rail and Ports on the Esri Transportation team. And today I'm joined by my colleague, Jim Barry, who is the Solution Engineer focusing on rail for the transportation team. So these webinars are designed to help illustrate how rail organizations can leverage GIS and location intelligence to become more efficient and ultimately become more successful in their digital journey and transformation. So as you know, rail plays a vital role in our global supply chains and a critical, I think, often underappreciated role in not only the national economy, but also in the economies of their respective regions. Today we hope to highlight that role in these webinars and to focus on how rail can leverage technology to increase competitiveness and collaboration within their larger environment that they operate in. So again, today we want to highlight a set of capabilities that we think will help rail agencies become more efficient and streamline their internal GIS operations. Looking ahead, we think there's some great advantages to consolidating the maintenance of different track networks and geometries, and being able to seamlessly generate information products, designed to help everyone in your organization be more productive. So you're going to see a number of these pieces today. But before we begin, I'd like to point out that we are recording this webinar, and while everyone will be on mute, there will be time for questions and answers at the end of the presentation. So go ahead and just type your questions into the question box, and we'll try to answer as many of those as time will allow. Additionally, just like the previous webinars, these slides along with the webinar itself will be posted online, so you can refer back to it or refer a colleague to it for future viewing. So with that, I'd like to pass it to Jim so that he can show you some of the stuff that we've been working on. Thank you.
All right, thanks, Mark. Let me get my screen going here. Okay, sorry about that. How are we doing? Can you see it?
I can see it, yes.
My screen, okay. Good, yeah, thanks. Again, I'm Jim Barry. I work with Mark here at Esri. I've been at Esri since '94. Been here a long time, worked a lot with ArcGIS in a lot of different industries, a lot of different applications. Last couple of years I've been working in transportation and particularly supporting commuter rail and freight rail organizations and their use of ArcGIS in order to improve their operations, in order to help manage that spatial data, visualize it, most often on a map, be able to analyze it and detect patterns of things that have happened, be able to model future behavior, and also be able to tie maps and assets, whether they be fixed or moving assets, with enterprise asset management systems, so that the GIS isn't a silo to itself, but it really absorbs within the rest of your enterprise technology implementation. So what we want to do over the past year, we've worked on a lot of different ways to apply ArcGIS to railroad operations, railroad maintenance, and engineering, and so forth. And so I want to just kind of run through what I like to call our next gen tools and techniques, and I boiled them down to a top 10. They're not in any particular order, and then at the end I'm going to kind of show you what we've been working on, and then at the end go through what we're working on next. And we would love to get your feedback on this. Some of the stuff I'm going to show is really oriented around solving business problems, and some of the stuff I'm going to show might be more attractive to some of the hands-on tech folks. I like to not only talk about what you could do and why, but also to make sure I talk about how to apply it, how to actually get this stuff working. So hopefully that's a nice mix there. And I've got a kind of a fire hose of information for you. I'm going to hit each one of these items in about 3 to 4 minutes each. If I show you something that really resonates with you, I'm going to show you at the end of this talk where you can get more information, a more in-depth video. But if I show you something that you don't like or doesn't really apply to you, don't worry, it'll be over in about 3 minutes and we'll move on to the next thing. And we are going to cover a lot of stuff related to schematic mapping, linear referencing, going to talk about artificial intelligence a bit and how that can be used to automate data collection and operational awareness. I'm going to talk about field mobility a little bit and also about data collection, not only in the field on mobile devices, but Lidar data collection and how we can update our data in a very accurate automated way with Lidar. And then finally, I'm going to finish with real-time GIS, real-time tracking. And you know what I'm going to do? I'm going to turn off my camera at this point so that I can use more of the screen here, but I'll come back with that later. Let me make a quick adjustment here. All right, so let's let me see. So from geographic data here at the bottom, which is what we typically do with a GIS, is to manage our geographic data, manage our maps, to understand how our stationary and moving equipment relates to the rest of the world, and using that and mashing that with other data for visualization and also for analysis. An important part of using GIS with railroads is that schematic maps, sometimes in track charts, sometimes in heads-up displays, sometimes schematic maps is the more useful way to represent rail networks. And if we can, rather than maintain those as two separate databases, the GIS allows us to make the schematic map a derivative product of the geographic map. That way they always stay in sync. I've worked with organizations that maintain those things separately at different tempos, and I'm going to show you a little bit of that there. Let me see, and then next would be to lay down some measures and calibration points in order to apply a linear referencing system or location referencing system that we can then maintain a lot of our data as dynamically as point events and line events. There's also, on top of that, is a utility network where devices have digital twin type behavior. For example, switches can control the flow of trains and isolate sections of track, all the way up to real-time tracking of trains, along with geofences for triggering geo-event behavior based on location and movement and position. So let's start with schematic maps. And let's dig in there. All right, so if you've got, when you have railroad data, it's often not only important to maintain your GIS data in geographic space, but also important to be able to display it in a schematic diagram. Like I mentioned before, many railroad organizations maintain their geographic data in a GIS separate from the tools and database that they use for their schematic maps, say for track charts, with different editing processes, different tempos. So it's very easy to get them out of date and out of sync. So in order to create a schematic view that makes sense and is intuitive for your users, it takes a little bit of editing to your data to add the network attributes to tell the schematic diagram tools how these tracks relate to one another. So here's a section of my railroad that I want to create a schematic map for. And here in this featured data set are layers for my railroad track lines and my switch devices for controlling the flow of trains. But before we can diagram our network, we need to build a trace network. Here, I'm going to be using the trace network tools that are included in ArcGIS Pro. It used to be if you wanted to create schematic diagram maps, you needed to use ArcGIS Utility Network or ArcGIS Schematics. But starting last year, you get this new set of trace network tools in this toolbox. And with this, not only can I perform some basic routing, tracing, and flow operations, but I can also use diagram tools for generating my schematic maps. This toolbox here has everything that I need. So before I go too far, I want to create network attributes that represent kind of the hierarchy of tracks when we get into areas that are a bit more complicated, like yards and such. So I've applied these network attributes to designate this hierarchy, and I've applied then a rainbow color to it to make it easier to see the relationship. So at a minimum, I need point and polyline feature classes. To start small, I'm using a polyline feature class of track and a point feature class of switches. And Trace Network needs these two feature classes to be in the feature data set, which is here. So I've got these feature classes, I've got the feature data set, so they use the same spatial reference. And then I can use those Trace Network tools. So when you drag the new Trace Network onto the map, you get a few of these layers down here in the lower left in order to help you find and resolve topology errors. We need to make sure that the data is really in there, the topology is set, the hierarchies are set so that the software does what you want it to do. So I select the tracks I want to diagram, and once your topology is clean, you can create a new diagram. And then when that is built, you can apply a diagram template to it. This apply relative mainline layout tool is specifically designed for railroads. There's lots of layout tools for lots of different purposes and industries, but this is the one really for railroads. And what that does is it ends up generating a nice, it does a decent job with these network attributes. I end up with a schematic that's clean and intuitively useful. It matches up pretty well. In fact, I'm not sure hardly anyone uses a rainbow color scheme, but I used it here so that you can kind of see the association of what's associated with what. Now, of course, here in the diagram, the y-axis is blown up quite a bit, and I get nice spacing here in order to get the benefits of the schematic. But I also want you to notice that the x-axis here remains to scale. So we have blown up the y-axis, but I keep the x-axis to scale. I found in railroads that that's very important. It makes it a little bit more intuitive, particularly if you're going to export this diagram to support your track chart maintenance. Track charts very often need that x-axis on the horizontal scale to remain to scale. Then what I can do, if I'm happy with the diagram, I can export it into its own regular feature classes, and then apply the same calibration points to it so that I can apply a linear referencing system just like the geographic data. If I want, I can even bring the schematic map into the same map as the geographic map. Of course, it does not match the geography to it anymore, but I have worked with railroads that like to have the geographic and the schematic in the same view nearby one another so that they can work with them simultaneously. So I talked a little bit about linear referencing, and so that's a good segue to go in that direction. So now that we've created the schematic map, we can build an LRS on it, a linear referencing system on both the geographic and the schematic maps, and so that we can synchronize the editing of event layers on both. My rail data in ArcGIS Pro, where I do all my data editing, as well as my analysis and design the map layouts from them. Here I got all my layers of rail data in regular geodatabase feature classes, but also built with a utility network, a trace network, and all of my event layers here that represent speed limit, curvature, grade, timber surface condition, and so on. And here, so once I pull that in, and I'm using location referencing, in this case, I'm using an extension to ArcGIS called Esri Roads and Highways, which helped me do this. And here are the two event editors. They're web-based applications for managing those event layers on the linear referencing system. Now, I've used those tools that I mentioned. The railroad's been built with routes and measures. And so now what we're going to do is use the event editor apps to create a new speed limit event on the schematic map. So here I've got the schematic map, the section of the schematic map that doesn't have the speed. I need to put speed there. And just, so I select that segment and I add a new line event here for the start and the end measures of the segment. And just to make it look different, I give it just to make it look different, I give it 45 instead of 40 around it. So I give it a different speed limit. And so there you go. The speed limit, the segment now has speed. Now what we want to do is we want to automatically sync that event over to the geographic map so that we only have to edit it once. This script here, written in using our Python API, scans through all of the new edits to the event layers, whether they be new, modified, or retired, and then we let that run. I can let this script run nightly, hourly, or on demand, or whatever tempo my business needs require. And then boom, that segment speed limit has been updated. Now they are in sync. So let's do this the other way. I want to add a new sign to the geographic view. So I select the location, the point location on the map, and it calculates the measure along that route. And this will be the new point event instead of a line event. And then I apply the attributes that I need. The sign is going to display how far it is to Canova Station. And there is my point event. Now I want the new sign on the geographic view to sync over to the schematic view. So again, I run this script, whatever tempo I need to handle all my edits since the last run. Overnight, once a month, on demand, that's totally up to you. And boom, that sign event that I applied over here is now synced to the schematic map. And while I'm displaying these maps currently in the event editor web apps, these event layers will also refresh in ArcGIS Pro, or it'll refresh in any web application, any native application, or any mobile application, pushing these edits automatically all the way out to my field workers right away. So here's yet another way to use your geographic and schematic maps, this time in a custom web app. This web app fuses 3 different map views together: a geographic map, a schematic map, and then a series of straight line diagram bands. This is, let me go over here and show you the application. Here is the application, and when I interact with the map above, it changes the view of what's going on here down below. If I pan this map here, it changes it above. So it keeps them in sync. Here is the source code behind this application that you can get to. It's not very large, but it has some basic things in here of finding the LRS location, referencing the REST endpoints for my location referencing roads and highways web services, being able to convert interactiveness in one map to the other, adding points to the map. I know if you're not familiar with JavaScript and web applications, this probably looks very cryptic, but there's really not much here. There's a method to the madness. And if you work with web developers and do custom web application development, it would make sense to those folks. Trust me. So anyway, this app here is built with our API for ArcGIS API for JavaScript, along with our web services. As I pan and zoom around the other map moves in sync. Then what I can do here is I can place a new point event on the geographic map, give it some properties, say it's an at-grade crossing at Gulf Road, and that new intersection appears here, but then is automatically synced over to the schematic view as well. Now what I want to do is change the speed limit for 1 mile north of this location. I can change the speed limits, I can change the grade, I can change the train director. All of these layers are layers in my event layers that work with my linear referencing system. And then I changed the speed limit of Gulf Road 1 mile north. Now, as you can see, the speed limit here is 25-35. Then it automatically updates that segment, that 1 mile section, changes the speed limit. And again, that data is pushed all the way out into Pro. It's pushed to my mobile devices, so on and so forth. So next, AI. Let's take a look at how artificial intelligence can be used to improve your operational awareness in real time, but also automate the process of collecting data in ways that you may not have been able to do before. So video, in this case, video of trains passing by can be used to build a deep learning model that recognizes trains, can count the cars, and can categorize those cars by type. So that given new video, the number of trained cars and their types can be captured and displayed on a map and dashboard and can be stored in a database for analysis and reporting over time. This solution uses the ArcGIS Learn module of our Python API, which encapsulates all of our artificial intelligence, machine learning, and deep learning capabilities, as well as ArcGIS dashboards. Let me go show you how that works. Let me see, where's my mouse? Here we go. All right, so here is my dashboard app. And when I click on one of the trains, it passes by, and the deep learning model not only counts the cars, but it recognizes that these are flat cars with containers on them. And it also categorizes these are flat cars with trailers on them. It also then recognizes, not only counts these cars, but it actually recognizes that these are locomotives because I trained it to know what a locomotive looks like. And as that each train goes by, I get the date time stamp. I store the number of cars by type in this database, and then I can use, not only display that in a dashboard in real time, but I can save this data over time. And there you go. Let me go back here to the slides. And so how did I do this? I'm not going to go into too much of the gory details, but really it comes down to, if you can train a person to tell the difference between a locomotive and a hopper, you can, and a box car, you can train a deep learning model. So here's a little application. I draw a box around each different type of car, and I label that as saying, hey, these are all locomotives. I drop this box and say that's an open hopper. Draw that box, that's a flat car with containers, a tank, a gondola. So I give it lots of examples of what these different things look like, and then it exports it. You know, it's a little bit of gory XML, but that's all under the hood. You don't have to worry about it. But then I bring this XML to this really short Python script, and that Python script with the AI module trains a deep learning model, and the more training data you use, the more accurate this thing gets. So if I give it 10 pictures of a locomotive versus 1,000 pictures of a locomotive, it's going to get better and better at it. Then once the deep learning model is trained, then I show it new video that it's never seen before. I give it the model, I give it the new video, and then it outputs a CSV file. Now at that point, I can convert the CSV file into a point feature class, into a hosted feature layer, which then I can display in a web map with all of the attributes that I'm looking for, and then display that in the dashboard that I showed you before. All right, so just to recap, here is the flow of how things went. It starts here on the left with the cameras that are capturing new video and sending those videos to the server and as new video files. Then those files are processed by the deep learning model that you trained. This is our new icon, by the way, for artificial intelligence. I couldn't tell what it was at first. It's a gear, and then it's got a brain on this side. It's a little gory, but anyways, that's our icon, artificial intelligence, gears and brains. Anyway, so then it outputs as CSVs that are fairly easy to import as hosted feature layers. And then I display that in a dashboard and combine that with my other data. And I made that accessible to anyone in the organization you want, either on an executive laptop or projected on a wall in an operations control room. But in short, we are taking these discrete repetitive tasks that it used to take humans to do and letting the technology automate that for you. Let me show you another example of this. In this next example, we're going to automate another discrete task with artificial intelligence, but this time we're going to use images instead of video. So in this example, the problem is simple. Given a camera that's aimed at an intersection, I want to be able to tell whether or not the grade crossing is fouled or not by a train. In this pic on the left, the locomotive is fouling the intersection. In the middle pic, it's clear. In this pic, is it fouled or not? That's up to you. If you want to call it fouled because the truck is there, great. If maybe you want to call it fouled if the truck is stationary versus moving, or you might want to say, hey, I only want to call it fouled if a train is there. That's totally up to you, and that depends on how you train the deep learning model. So the first thing we need to do is train it. So I'm showing a bunch of images of a train that's fouling an intersection and one that's not. I do this during the day. I do this at night. It'll help if we have those examples as well. In fact, here's an example of cars that are sitting on the track. I am going to call that not fouled as long as they're moving. But if I sense through repetitive images that they are stationary, then at some point I can trigger that and say that is fouled. So again, we've got a little Python script. We train a deep learning model. The more data we have, the better it'll be. And then what I do is I take this model and I give it new images it's never seen before. And for each image, let's say they're coming in once every 5 seconds, this predict method here will immediately tell you whether or not the AI thinks that intersection is fouled or not. And let me show you how that works, what that looks like. Okay, so here's an example of an intersection. This comes back as true, it's fouled again. 5 seconds later, it's not fouled anymore. 5 seconds later, it's still not fouled, but that's only because the truck is moving. 5 seconds later, the truck is gone. Here's another example where I've got an intersection, and I've got 3 intersections actually, and green tells me that these grade crossings are not fouled. 5 seconds later, it's not fouled. 5 seconds later, it is fouled. Not only do I see the picture, not only is it recording it for posterity, but in my operations center, I can automatically turn that icon to red. I can zoom in and zoom out on it if I want. I can change the base map if I want to something more of imagery. That's totally up to me. So at that point, you can use this data any way you want. Let me go back to my slide. Yeah, so for example, I can change the symbol on the map. All this data is being stored, record keeping, analysis over time, throw it up on a display wall. I can combine this with weather data, with Waze data. The possibilities are endless at that point, because the point here is this. I'm automating the collection of data that used to take people to do, or maybe it's collecting data that I never was able to collect in the past, and you're using AI to do it with some video, with some images, and some very small Python scripts for doing that. Okay, so let's take a look at a robust industry-proven tool set and how it can be used to support railroad mapping, and that is the utility network. So in the scheme of things, here's where I mentally kind of put it, is so that we can do routing and tracing in a digital twin type of way and control the flow of trains through the network. So what is utility network? Well, it was originally created for the electric industry, but then it was expanded to also apply to the natural gas delivery, water delivery, wastewater, and telecom. Well, what we decided is that rail networks have a lot in common with those types of industries with regards to controlling the flow of things through a linear network. So that's what we've pursued and started playing around with. Now, while its use in transportation is limited so far, we recognize that railroad mapping is not just digitizing the world into points, lines, and polygons. You want to build behavior into these devices in your map as well. All right, so let me see here. So let me see. Oh, another advantage is that railroads are often associated with other kinds of networks. In this graphic here in the upper left, we have a railroad network associated with an electric network. So if you have overhead catenary-based overhead power cables, or maybe third rails, or an electric network in your right-of-way that is powering grade crossing arms and signals, you can then maintain those together. So here's my rail data in ArcGIS Pro. It contains my geographically referenced data, my base feature classes, my LRS based event layers. And here you're seeing some rail lines that split using track switches here at these triangles. When I perform traces or find shortest paths, these tools will respect the behavioral rules of that switch, not only modeling how switches work, but how they behave when set in different ways. So let's say I have a train that's going from here to here. Very simple example with these green circles. And when I do a shortest path trace, the path will be found, and that's represented in this light blue, because this switch here is in its default setting, which allows the train to go this way and proceed along the main track. Now, if I move the trace location to over, let me see. Yeah, if I move the trace location from here to here and then do the same type of trace, it's going to say that a no path was discovered. And that's correct. That's what we want, because this switch only allows the train to go in this direction, not this direction. So if I change the switch and say, hey, instead of staying on the main track, go to the right, then when I do that same exact trace again, now a path will be found because it goes through this switch and goes here. So what we're doing is we're modeling the real world behavior track switches onto the devices being mapped in the GIS. Here at the top left is a cool little animated GIF that I made. I'm really proud to show you of a switch being activated in order to direct the train's path this way or that way. A train can go out this way or out that way, or it can approach from here or approach from here. But what it can't do is it can't come in from here and make a left turn and go that way. We all know that. So let's model that digital twin wise in the network. It can go this way and this way, but it can't go this way. And one of the reasons why we may want to do this is, let's say we need to do some maintenance of way operations, maintenance operations on this track. We want to set all of these switches so that the flow of trains goes around it. And I know I did that in a manual way in ArcGIS Pro, but all of these capabilities can be automated with our various APIs and customized for you. Let me see. Let's go back to here. Okay, so looking at the entire loop, you'll see that the path stops here at the bottom. It does not continue. So let's move the second green trace point back onto the main track. If we ran a trace right now, it would fail because this switch is pointed in the wrong direction. So let's change that bottom switch so that it goes the other, so that it brings the train back onto the main track, and boom, now a path can be found. So at the top, we're switching this way to bypass the main track, and at the bottom, we activate the switch to pull the train back on the main track. We've effectively isolated this piece of track off of the network, and we may have various reasons why we want to do that. That's totally up to you. Okay, so that's one way, a very simple way. Of course, utility network, a data model for railroad for utility network can be a lot more complicated than that, but I just wanted to touch in a couple of minutes how that can be done. We can deep dive on any of this stuff that we're covering today. So let me touch upon field mobility now. How do we get these maps, these linear referencing, these dashboards, these tracing, routing capabilities? How do we push that all the way out into the field so that your field workers are working with live dynamic data rather than static data, who knows how old it is? So here's a case where we've got a lot of maintenance tasks and we're using ArcGIS workforce in order to maintain all of this stuff. Back at the maintenance managers has this view of the track and all their devices and all their maintenance tasks. And that maintenance manager says, hey, I've got a high priority item here in red of a signal repair that needs to take place. So I assign that to my worker in the field. They don't have to come back. And then I say to myself, well, here's a switch, These switches need to be activated to isolate this track. So that's another task. It's a critical task that I need to assign to this maintenance worker as well. Now what I want to do is I want to take a look, hey, what other maintenance items, even if they're very low priority items, what other types of maintenance items could benefit from that section of track being flagged out? And I can assign those to my maintenance worker as well. Now, what's happening back at the organization is a read-only view for executives or projected back on a wall in a display where I see a track that is currently flagged out. I see a track another track that's flagged out, but then I've got a green dash line, and that might mean it's due to flag out sometime in the future, but it's still in operation. So I might be in another department in my organization saying, hey, this is going to get flagged out, say tomorrow. Do we have any reason to be out there? We might want to take advantage of that. So it increases communication within your organization. Now here is the track that I assigned to my field worker along with these other tasks, the high priority one and the low priority ones. And back on the executive dashboard, it displays as green. Now, when my field worker on their tablet goes ahead and flags that section of track out, automatically that dashboard back at the office will turn from green to red. That way everybody knows that field worker with the tablet just turned that section red. So everybody knows that it's flagged out. Now the maintenance worker in the field, they do their work on the signal, on the ballast, on the overhang, in the overpass, on the station. Their maintenance items are all done. And as soon as that maintenance worker in the field marks that track as being back in operation, the dashboard automatically changes from red back to clear, which shows everybody that it's back there. So that's one way to not only assign work to workers in the field, but use dashboards to give the rest of your organizational visibility into not only what's going to happen in the future, but also what's happening now. And then all of that is stored historically for analysis later. So let's give another example for field mobility. One of the challenges is part of the digital transformation that railroads are faced with relates to digitizing paper forms and streamlining these workflows for collecting data. So here's a basic example of how this can be done. This is a stock strike report that train crews need to fill out when a train collides with some type of livestock. As you can see, this form has probably been around for a while, probably since before the war, or maybe since the first war. In fact, it says 19 right here, so it's a pretty old form. Now, this isn't just about creating a digital workflow per se. It's about streamlining the process so that you could do more with less, as well as reducing the number of steps. For example, moving this form into a tablet device eliminates the need for about a third to half of the inputs. If the user's logged in, if we know the train number, the road number of the locomotive, the date, time off of the device, as well as the GPS on the device pulling the location, now we have a much simpler form with fewer and more accurate inputs. So we have a form-driven data collection called Survey 123 that makes it easy to do this type of thing. So I took that relatively simple stock strike report and started designing it line by line, of course, leaving out those things that can be automatically captured. So far as the location, again, we're pulling that off of the GPS and so forth. So what's going on now, I'm in the field with the iPad. I start filling out the form. I'm pulling the GPS off of the device. I can also use pictures. There's the cattle. He's not very happy that I struck. There's the first responders doing first aid in the field, taking a picture, and I'm attaching those pictures as attachments to the form, filling out the rest of the form, and then I can submit that automatically, and it goes straight back to either the data QA QC or going straight back into the database. So each survey enters in there automatically. Now, if you have a data connection, it just goes in. If you have intermittent connectivity, that happens a lot with railroads, particularly freight railroads in the middle of nowhere. The app is designed to automatically sync that data back to the office next time it senses a connection. Or You can leave connectivity off altogether and just sync it up when you get back to the office. That's totally up to you. Now, when I click on each one of these reports, I see the data that was collected and the attached photos. So all the attributes, all the attachments are in this nice web map. Here's one of the things I could do. We can analyze this data in order to find patterns, use mapping tools to sense patterns just by looking at the map. Here are all the reports of stock strikes in North Dakota. But if I apply a heat map render, the areas around the state that are worthy of further inspection pretty much pop right out at you. Perhaps there's fences down or damaged cattle traps that are allowing livestock to be on the tracks. But at least now you have a better idea on how to make the most improvements with the least amount of time, money, and effort, because you're using analysis and visualization tools to prioritize your work. Now, while the stock strike data collection is sort of a reactive incident report, this same type of approach can be used to create proactive asset inspection forms, like in this case, a grade crossing inspection form. Here, again, you're reducing the data inputs by automatically pulling some information off of the device. That reduces steps, increases accuracy, consistency, standardization, all good things. So by digitally transforming your paper workflows, it's not just jumping onto the tech bandwagon. It has all of these benefits that I mentioned. We're not losing forms. Readability is good. We can make fields mandatory so that we're not missing information. We're using the device, pulling information. We're storing in the database. We are reacting to things. We are proacting to things. We are analyzing things. We're sensing patterns. We're prioritizing work. We're saving money and increasing safety. All right. So next is Lidar. A lot of railroads are capturing Lidar. Lidar is a great way to very accurately and relatively inexpensively, comparatively, collect a lot of data, update a lot of data real fast. So now with these previous Geo AI examples, I built the deep learning models from scratch using training data. That's what I showed you a few minutes ago. But in addition to building these models yourself, the ArcGIS Living Atlas of the world has an ever-growing list of pre-built AI models that you can use straight away. All kinds of these examples of what we're finding are very common use cases for AI. New models are being built all the time. The Geo AI development team at Esri is always looking for ideas and data sets for building more of these things. In fact, let me go here. Let me show you something real quick. In fact, there's a recent blog article from that team where when they build these new models, they write a blog post on them and show how you can use these deep learning models straight away. Quick little video showing you how to do it. Even if you've never worked with AI before, you don't need to be an expert in the technology under the hood. A lot of this stuff is doing the heavy lifting for you. Let me go back to the slides here. Okay, so let's use one of these models. So during field inspections, the dimensions of these railway assets are measured manually, which is not only time consuming, but it's also prone to human error. So in this example, we can automate the process using point cloud data from Lidar. In this case, the user can collect and then over time update data layers like power lines and poles, but also catenary cables and cantilevers and power lines, along with other wayside equipment, and not to mention the track itself. So on the left here is the raw Lidar data that's collected, and on the right are all the measurements that we want to extract and store and do that automatically. Now, one I want to draw your attention to is a pre-built model currently in production with electric utility companies called power line classification. Let me show you this real quick for a second. This is a model that was built for the electric industry called power line classification. So if you pull Lidar in order to collect data for your power lines, we said to ourselves, well, I wonder if overhead power cables with overhead catenaries with railroads would respond to the same data model, and we'd be able to use it for railroads as well. And it turned out it worked pretty well. And it shows you, how to use it and so on and so forth. But that's the gory details. Let me skip over that for now. So here's our raw data that we're collecting. And then when we apply that pre-trained model that was built for the electric industry, it collects that data and it recognizes the difference between a pole and a power cable and classifies them appropriately. Let me see. So what we do is we might want to make some adjustments. If so, we can prepare that data and fine tune that pre-trained model, or maybe just use it as is. But one of the things we found is while it was picking up the power cables and the poles, it was not picking up the cantilevers nor the track. So we had to build a model to pick those up. And then, but we can combine those two models. We can combine the pre-built model with the model that we built and combine them into a model, into a geoprocessing model. So here's the result. We've got the pre-built model, found the poles and the wires. Our model found the cantilevers and the track. And then when we combine those together, now we've collected all the data that we're interested in collecting. Now, the next thing we do, it's not over yet. Sure, we've collected all that data, but remember, one of the things we wanted to do was not just collect the data, but also make those measurements of the pole height and the measurements of where the cables are and see if they've changed over time. I know this looks a little complicated, but long story short is we're combining the data collection with the AI, with the measurements, in order to then get the measurements of the track very accurately, get the measurements of the poles and the cables very accurately, measure the catenary height, the contact height of on the cantilevers accurately, and then even down to the top fittings and bottom fittings. And all that's being collected in an automated way. All right, so that's Lidar. There's another example of using Lidar. I'm going to touch upon that here in a little bit, but I want to just keep on moving here. And the last thing I wanted to show you is about using real-time location data. And the couple of points I want to kind of have you take away is where we can track moving assets, we can boost real-time monitoring, make better decisions in real time, and also combine your track train movement data with other live feeds. So here we've got Hostler locomotives moving around, pulling AVL data. On the left, we have current locomotive positions, red are active, gray are inactive. If I click on one, you can see more info in the pop-up about that locomotive. The AVL may have other information as well about vehicle status, mileage, fuel used, and the location can trigger a geo event. Say if it's within 1,000 feet of a critical intersection, I can pop up a geo event. Now, I know where the locomotive is because that's where the AVL is. But as you know, the rest of the cars don't have onboard GPS. The rest of the cars might be kind of dumb location-wise. But if we combine this with the other thing that I showed you before, this was an example of using AI to also know where all the cars are and what kinds of cars there are. So this is a case of using Geo Event Server for location and AI for not only knowing the location of the locomotive, but also being able to know the location of the whole train. All right, so we're supplementing one with the others. But as long as the train is moving, we can see the location that it's moving. Like the location was here, now it's moved to here, and we see that in real time. So here's a stationary locomotive. We can set up a geo event that triggers how much time the train resides within that fence. Here are some graphics here that show how geofences work. It's fairly intuitive, I think. We can connect different actions based on business rules, different locations and movements and speeds and directions, what have you. The track moves into the fence, I can have one action. If it moves out of the fence, I can have another action. If it resides in the fence for more than a certain amount of time, I can do another action. If it's moving, I could do one. If it's stationary, I can do one. So I can use, set up different types of actions depending on that location and movement behavior. All right, so the thing about this event list here on the right, or this entire dashboard for that matter, is no custom code was used to create it. This is completely configurable, no code, out of the box, configurable to connect to your data. And this is where it gets cool, because not only can you have, not only do you have your static layers in there and also your live streaming data, but you can also put other streaming data in there too, like Waze data or weather data that you can tap in and display that stuff at the same time. For example, here I've turned on Angel Tracks, traffic from Waze, weather data as well. All right. And for more information on that real time, because it's relatively new, feel free to contact us at this email address, whether you want to implement real-time GIS or with ArcGIS Enterprise. You can also do this fully online on the Esri cloud through ArcGIS Online through a new product called ArcGIS Velocity. You can do that online, fully on-prem, or a hybrid in between. So that was my fire hose. That's my top 10 list. This is the stuff we've been working on, and I hope you found it enjoyable. Now, I know I only hit each one for 3 or 4 minutes. If you go to YouTube and search on Esri Rail, you'll find our Esri Rail YouTube channel. And Mark uploads these videos periodically. We're always refreshing this stuff. Every single thing that I showed has a longer deep dive video about this that backs it up a little bit more with live demos. You could also contact Mark or myself for more information on that, and I'll get to that in a moment. So what's next? I mean, we're constantly looking for new ways to apply GIS to railroads. That's a nice picture, a couple handsome guys there. I'm on the left, Mark's on the right. We got orange safety vests and helmets, you know, being real safe. We want to use Velocity and build out a railroad example. So if you want to use that fully online, we can show you an example. We want to take that utility network and more fully run it out. We want to combine it with an electric network. More interactive facility maps for vehicles that are moving around, say at a facility. I would love to get my hands on some PTC data, maybe that's coming out of a PTC, to analyze that over space and time in order to close that feedback loop. Engineer trip report, yard inspection report. I showed you a little bit of Lidar, but I know that there's some railroads that are through a car collecting that Lidar data in order to capture a travel envelope, which can help in many ways, perhaps to support prioritized vegetation maintenance, and maybe explore some ways that GIS can support your precision scheduling and precision schedule railroading. So these are just some ideas of things that we have in the hopper that we're working on. But what do you want to see? What would help you? What kinds of things are you working on that you think we can help you with? This is not just about here's the technology. We're committed to really making this, squeezing every ounce of value we can out of ArcGIS. We also created a hub site that you can use to contact us, and we will populate this with news and events and all kinds of new stuff. This is relatively new. We just stood this thing up, this hub site. Check in there often for new videos, new announcements, events, and stuff like that. So with that, I know I've done a lot of talking here, but I wanted to kind of do my best to use your time effectively. And let me turn my camera back on here. And I'm going to turn it back over to Mark, who may have a few more things to say. And I think maybe we have some questions that have come in, and we're going to take the last few minutes of this webinar, I think, to hit some questions. So Nadine and Mark, let me turn it back over to you guys and take it from there.
Sure. So can you hear me okay, Jim?
Yes.
Great. Yeah, we did get some questions. Let's just start with, of all the things that you showed today, what release of ArcGIS Suite is needed to access these capabilities?
Okay, yeah, great question. I mean, to build these things and really work them out, I tend to use the versions that are in the general availability phase of our product lifecycle. So some of you may, product support lifecycle, some of you may know there's 4 phases. There's general availability, which are the newest version or 2 or 3, then extended support, mature support, and then retired. So I can tell you that everything that I'm doing applies to those versions. The 10.9x, might some of them also work at the 10x? I'm sorry, the 10.8x. Yes, I haven't fully tested those. Some of them may, some of them might, maybe they all do. But for the most part, I am testing them with every version that is in general availability for ArcGIS at the moment. But if
Sure.
you are running with an older version, and I know some of you do because you have other dependencies and you have other processes for updating software, we could take that offline, something specific. I'd happy to be able to test that for you. And if something needs to be adjusted, if we can get it to work with some adjustments, we can try to do that as well.
Sure. Okay, and then I've got a few around, creating and updating schematics. So, how does the GIS to track chart process scale, for an entire subdivision, 100 plus miles, section by section?
Right. So how does it scale? Well, you can do an entire line at a time. You can do them section by section, or you can do an entire network at once. I've done this. Now I know the sample I showed you was a tiny, tiny little section. That was really just for demonstration purposes. But you can do it as small or as large as you want. Of course, if you have a lot more data, the processing time might take a little bit more. But really, the flow is pretty much the same. The flow is to do all your editing in the geographic data in the GIS, and then periodically, either on demand or periodically in an automated way with scripting, automate the pushing of those edits through the diagram template into your export diagram. And at that point, you're using it as a diagram in ArcGIS Pro, or you can then export that as standard feature classes that you can bring into any other map, or export that into data sets, exchange formats that you can use, whether they be JSON, GeoJSON, or some other type of format, so that you can then import shapefiles or DXF or some other format that you want to bring if you have your own track chart maintenance tools. What we want to do is find ways to get that data ETL'd into your software. How does it scale? Well, I mean, data editing takes work, and sometimes it has to be done manually first. But the cool thing about GIS and our Python scripting and our building of models and templates is once you have a set of steps that you're going to want to repeat, you're definitely going to automate those to make the manual steps as few as possible and use the automated steps as much as possible. So I've done this with an entire railroad. You said, let me see, I think the largest I've done so far is probably about 200 miles. Most of the testing I do is on a section of railroad of 81 miles. But of course, it can go all the way down. So that might take some work, I'll be candid with you. But again, it's the philosophy of editing in the geographic, always make the schematic a derivative product that you're pushing, and then automate that stuff wherever possible. And we'd be happy to give you some advice. If you need to hire some of our professional services to actually wire that up for you, that's available as well.
Okay, thanks, Jim. So we've got a lot of questions, and we're not going to be able to get to all of them.
Okay.
So I encourage you guys to reach out and to Jim and I specifically, and we'll schedule some time to talk through it.
Hey, Mark, can I say this? If you've got a lot more questions, this is what we're going to do. After this, Mark and I are going to team up on these questions and answers, and we're going to publish a blog article, and then we're going to put that blog onto that hub site and send it a link to it out in a post email survey, so that we'll go ahead and answer all the questions that you gave us. We'll just do it in a blog Q&A format.
Perfect. All right. So one last one on the track charts. Does the system extract curvature of the track segment automatically from the geometry?
No, it does not. There would be a way to script that if we understand the logic of, because we know we have the feature geometry. I have never written a script for how to extract that manipulating the geometry itself and the angles, using a little bit of trig in there to do that. But that is in theory scriptable. We don't have an automated tool to do that, but that would be a really interesting thing. You know, I've just added that to my list of things that I want to kind of R&D, so that we can then, you know, for every section of track, measure what its curvature is in the context of track before it and after that, and then apply that curvature value into the curvature event layer. Definitely doable, not out of the box, would need to be scripted, but that might be a thing. I mean, it's doable. I'd like to work on that.
Sure. Okay, and then we got to jump into AI and Lidar a bit. You know, there's a question that, you know, can Esri AI recognize not only wagon type, but also wagon number? So wagon type is a yes. Wagon number, so locomotive number would be easy, right? Because it's located in the same exact place every time. The issue with wagon number is it's not always in the same exact place. It's not always the same same shape, same size, same length.
You're absolutely right. The more standardized it is, the bigger it is in the video and image, the better job we're going to be able to do to OCR that out. Basically turn a picture of a number or picture of a sign or a name into a digital thing. That's OCR. We have that. We do that a lot with highways and highway signs and stuff. But yeah, if the number's really small, it's not in a predictable location, we still can do it because we have AI that can sense what in the image in the video are words and numbers. But again, it's going to have to probably be a lot more training data. You know, that's one of the things about AI is that, you know, the more training data you have, the better it is. And it's hard to get perfection, but it is better than doing things manually. I know we're starting to run out of time. I hope we didn't get cut off already.
I think we're going to spend a lot of time on PointNet. I think in the blog, there's a lot of questions around PointNet. So one thing on your real-time rail, as you go from a point cloud to a multi-cloud, is there a recommended data set, like extension or resolution?
Yeah, I know we're way over time. There's so much I want to say about that. Can we push? Great question. I'm going to answer that question. Can we push that into the blog?
Perfect. Let's do that. And let's push the rest into the blog. We've got a good number here.
Yeah, that's a long one.
Okay, great. Well, guys, thank you very much for joining. We will answer all of these questions. If you want to learn more about any of these, please reach out. Of course, as Jim mentioned, we have the YouTube videos posted, as well as our website. So thanks again, and you guys have a wonderful day, and we appreciate your time.